Unit 2, Retake Practice. The entire thing is no calculator, so make sure that you're working through this practice without a calculator. Solve the system algebraically. Make sure you show all algebraic work. Number 1, we're going to start by labeling our equations A, B, and C. We need to determine which variables we want to try to eliminate. I think I'm going to go with the x's. When I add these two equations, the x terms zero out. I get 4y minus 6z equals negative 16. That's my equation D. For the second step, I have to use equation B. So I've got 3x plus y plus 4z equals 16. And I have to use, I can use either A or C. If I do 3 times A, I'll get negative 3x plus 6y minus 6z equals negative 27. Make sure you double check signs and coefficients if you're multiplying an equation by a constant. It's an easy place to make mistakes. The x terms zero out. I've got 7y minus 2z. Negative 27 minus 16 is negative 11. That would be my equation E. Now I need to combine D and E. Looking at the coefficients, I can multiply E by negative 3 in order to get the y terms to drop out. So I get negative 21y plus 6z equals 33. Negative 21 plus 4 is negative 17y. Negative 16 plus 33 is 17. So y equals negative 1. Now I need to take and substitute the y value back into one of the equations D or E. Can add 7 to both sides, divide by negative 2, and I get z as 2. Now I can go back to one of the original equations to calculate my x value. Negative 2 minus 8 is negative 10. So I get x equals 3. So my solution is 3, negative 1, 2. Number 2, we are going to use the exact same strategy. Start with labeling A, B, and C equations. I am going to work with eliminating the y variable. So I'll start with adding A and B. That result gives us our D equation. Now I need to use C and also eliminate the y value. So I'll combine that one with 2b. That gives me an E equation. I'm going to have to multiply both equations by a constant to get something to cancel out. So if I multiply D by -3, I get 15x minus 15z equals -60. And I need to multiply E by 5. So -15x plus 35z equals 100. -15 plus 35 is 20. Z, -60 plus 100 is 40. So we get Z equals 2. Using the E equation to substitute, I get -3x plus 14 equals 20. If I subtract 14, I get 6. And divide by -3 and we get -2. And then I can go back to an original equation and substitute x and z to find the y value. -2 minus 2y plus 2 equals -8. -2 plus 2 zero out, so I get -2y equals -8. So y equals 4. So the solution to number 2 is -2, 4, 2. Number 3, graph the system of inequalities. To start with these, we need to make sure we put them in y equals mx plus b format. So if I take the first equation and subtract 4x, then I am left with 3y is less than -4x plus 9. And then I need to divide everything by 3. So the first equation rewritten is y is less than negative 4/3 x plus 3. I need to do the same thing with the third equation. So if I add 9x, then I will get 6y is less than 9x plus 18, and divide everything by 6. 9 over 6 reduces to 3 halves plus 3. So to graph these, start with the intercept, and then use the slope. So down 4 over 3. And because it is less than, it is going to be a dotted line. And we will shade below. This equation will also start at positive 3, but we will go up 3 over 2. And it again will be a dotted line. And we shade below because it's less than. And the third inequality, y is greater than negative 2. I go to negative 2 on the y-axis. And it's going to be the horizontal line. And since it is or equals to, it is a solid line. And we would shade above. So the solution for this inequality is represented by this shaded triangle right here. Now, to determine how you know whether a point is a solution to a system of inequalities, it's important to know that dotted lines are never included in the solution. Solid lines where it borders the shaded area are included. Solid lines outside of the shaded area are not included. Number 4, write a system of equations and the corresponding matrix equation for the situation below. Do not solve. So we're just setting up the equations for this problem. Janie is setting up a lemonade stand. She needs to buy lemons, bags of sugar, and cups. She needs twice as many cups as she does lemons. So that piece will give us one equation. She needs twice as many cups. So that tells us that cups is the larger value. So cups is going to equal twice the number of lemons. She buys 73 items for a total of $15.68. If each lemon costs 25 cents, each cup is 15 cents, and a bag of sugar is $2.48, how many of each item did she purchase? Well, we can use the total number of items to write one of the equations. So we have lemons plus a bag of sugar plus cups will equal a total of 73 items. And then we can use the value, or the cost, to write the third equation. So a lemon is 25 cents. A bag of sugar is $2.48. And each cup is 15 cents for a total of $15.68. So that's the algebraic system of equations. The matrix equation we need to make sure we have all our variables lined up. So I need to take this first equation and rearrange. So if I leave the 2L positive, I could subtract the C, and that would leave me with the equation equal to 0. So the coefficient matrix, if I use this as my first line, will be 1, 1, 1. If I use the values as the second line, will be 0.25, 2.48, and 0.15. And the third line will be 2, 0, -1. The second piece of the equation is the variable matrix, so I need to make sure I identify that the variables go in the order L, S, and then C. And then the constant matrix would be 73, 1568, and 0. And since it doesn't ask us to actually solve that, we're done with that problem. On the back, number 5 and 6, write an equation for each absolute value function in the format of y equals a times the absolute value of x minus h plus k. So we will be using the vertex and a point to calculate our a value. So the vertex gives us h and k, the point gives us an x and a y value. So we'll start with plugging those into the format of the equation. So we have -7 equals a times the absolute value of 2 minus -4 gives me a +4, and then +5. So I'm going to subtract the 5 first and get -12 equals a times the absolute value of 2 + 4 is 6. The absolute value of 6 is 6. And then I need to divide by the 6, so I get -2 for my a value. So my equation is y equals -2, absolute value of x plus 4 plus 5. Using the exact same process for number 6, again the vertex is h and k, point is x and y. So we have -3 equals a times -7 minus 2 minus 6. So we start with adding the 6. So we get 3 equals a times -7 minus 2 is -9. The absolute value of -9 is +9. So we have 9 times a equals 3. Divide by 9 and that gives us 1/3 as our a value. So y equals 1/3 times the absolute value of x minus 2 minus 6 is our equation. For number 7, we are listing all the characteristics. So we're always going to start with transformations. The negative in the front of the equation tells us that there is a reflection over x axis. The 3, since that value is greater than 1, tells us there is a vertical stretch of 3. X minus 4 tells us that we are moving to the right 4. And the -1 tells us we're going down 1. So right 4, down 1 directly translates into our vertex. So that will be 4, -1. The axis is symmetry, has to go through the vertex, so that equation will be x equals 4. The domain of all absolute value functions is -infinity to +infinity, or all real numbers. The range, since this is reflected over the x-axis, it opens down, so the range has to be -infinity, and the highest value will be at the vertex, which is -1. You've got to use a bracket on that because the vertex is included in the function. Our end behavior, since it is reflected over the x-axis, they will both approach -infinity. Again, since the function opens down, we will have a maximum, and these values will come straight from your vertex, so we use a maximum value of -1 at x equals 4. When the absolute value function is reflected, the increasing section is going to be on the left side. So that will be -infinity to 4. And the decreasing will be from 4 to infinity. Going through the same process on number 8. The transformations, I have a 1/2 as my a value, so that tells me there's a vertical shrink of 1/2. X plus 2 tells me I'm going left 2. -3 says down 3. So this absolute value function is still opening up, so our end behavior will be +infinity for both. Domain is still all real numbers. The range will be from -3 to +infinity because it opens up. The vertex comes from going left 2 down 3. So we go -2, -3. Axis of symmetry will always be x equals your h value, which is -2. Because it opens up, we'll have a minimum of -3 at -2. The right side of this function is increasing, so that will be from -2 to +infinity, and the left side is decreasing, so that will be from -infinity to -2. Numbers 9 through 14, we are solving these equations and inequalities. So remember your steps. First step is to isolate. Second step is check for negatives. Third step is to write it as two separate equations to get rid of the absolute value. And then we solve normally and check our answers. So on number 9, the absolute value is already isolated. There's no negative. So I'm going to go ahead and split this to remove the absolute value. So I have 4x plus 8 equals 12, or 4x plus 8 equals negative 12. Subtract 8. Divide by 4. X equals 1 or negative 5 are my solutions. Number 10, we need to isolate first. So I'm going to add 8 because we use order of operations backwards when we are solving for a variable. Divide by negative 5. Because in this line right here, where I have an absolute value isolated is equal to a negative number, I can stop working and say there is no solution. Number 11, start by subtracting 7. So I have 2/5. X plus 10 is greater than negative 4. To get rid of the 2/5, I need to multiply by the reciprocal on both sides. So absolute value of x plus 10 is greater than negative 10. So the absolute value is isolated, and I have greater than a negative number. Since the absolute value will always yield a positive is always greater than negative 10. So my answer here will be all real numbers. Number 12, start by isolating the absolute value, so I start by adding 3. So you get negative 12. When I divide by negative 3, anytime I divide or multiply by a negative number, I have to switch the direction, flip the direction of the inequality. So this line right here is where you want to check for negatives, and you also decide whether this is an and or an or statement. You don't want to do that at the beginning. You've got to do it when the absolute value is isolated. Less than will be an and statement, so I can combine it into a compound inequality. So I put negative 4 is less than or equal to the x plus 6 comes out of the absolute value is less than or equal to positive 4. And to solve for x, to keep this balanced, we subtract the 6 from all 3 pieces of the equation. So we get negative 10 is less than or equal to x is less than or equal to negative 2. Number 13, because there is an extra x outside of the absolute value in this equation, I have to check my answers for extraneous solutions. So x plus 7 equals, if I subtract the 9, then I get 2x minus 10. If I divide by a -1, I get negative 2x plus 10. Now I need to split this into two separate equations. The first one will be identical to what I started with without the absolute value bars. The second one, I need to change the sign of everything on the right side. So I'll have a positive 2x minus 10. Now I solve each one normally. So if I add 2x, and subtract 7, and then divide by 3, I get x equals 1 as a possible solution. On this side, if I subtract x and add 10, I get x equals 17 as a possible solution. But I've got to check both of these. So to check the 1, I plug in a 1 for every x in the equation, and I want to make sure if this is true or false. So 1 plus 7 is 8. The absolute value of 8 is 8, but then I have the negative that happens afterwards. So that is negative 8 plus 9. This is 2 times 1 minus 1. So I get 1 equals 1. So x equals 1 is definitely a solution. Let's check 17. Seventeen plus 7 is 24. The absolute value of 24 is 24, and then we take the negative. 17 times 2 is 34. Negative 24 plus 9 is negative 15. 34 minus 1 is 33. So x equals 17 is an extraneous solution. For number 14, start by subtracting 4. (22 minus 4 is 18. I need to divide by 6 and get 3. I don't have a negative to worry about, and this is greater than, so I'm going to use an OR statement. So x minus 10 is greater than 3. So again, one of these matches identically to what was the original. Or x minus 10 is less than negative 3. The one that you turn negative, you have to flip the inequality. If I add 10, I get x is greater than 13. If I add 10 over here, I get x is less than 7.